This is Professor Thomas. I'm the founder of the Math Guru Academy. If you don't know what that is, you may want to check it out, register, so on and so forth. Today, we are going to be discussing how to solve linear equations with fractions. And by the way, that website for your references is www.mathematical Google. It is a place to learn and to study mathematics, and much of its applications is vast. And so what we're going to be doing is attempting to capture a fraction of it and develop web applications in the process. So it's really excited about the project. So now today we're actually going to be studying from the Mathematics 84 textbook. If you need a copy of this particular book, reach out to me, contact me. My email, I can be reached at services@mathematical.guru. And I will be happy to send out an ebook of this book if you need it. Okay, let's get started now. And we're basically just going to be reading through the book, working out the problems, and hopefully this will be very beneficial to you. As I did say, you must have mastered computations on fractions. You should know how to add them, subtract them, multiply them, divide them. You should know how to reduce them, work with mixed numbers, improper numbers, and things of that sort. Okay, and I will create a video in the future about a fraction challenge. So stay on the lookout for that as well. So it starts off with the objective. It says solve linear equations. And so now that we have learned how to solve one-step linear equations, so we are ready to solve any kind, which are basically the two-step, two or more steps now. So as in the previous section, our goal is to isolate the variable because that's what we want to solve for. So we want to know what the variable is equal to. So in order to figure out what the variable equals, we will have to isolate it. The basic idea to achieve this will be to use two properties covered in the previous section: addition property of equality and the multiplication property of equality, one at a time. And so our first example appears to be pretty straightforward. Not much really going on there. It appears that we have this example. It's 3x plus 4y equals 13, and our job is just to simply isolate our x term. So the first thing we do is subtract 4 from both sides. Okay, maintain equality. This relationship is equal to this relationship, and if I subtract from the left side, and I can also subtract from the right side and maintain equality. And so surely 3x is equal to 9. And now, of course, how do we get our x? How do we solve for our x? I know what 3 times x is equal to, but I want to know what x is equal to. And so it appears to be a little typo right there. If I have the problem 3x equals 9, I need to divide both sides by 3. And when I divide both sides by 3, I still maintain equality. It cancels out, and I get x is equal to just 3. Notice that, again, if I have 3x equals 9, dividing by 3 is the same as multiplying by 1 over 3. But we don't really say that. It's like it's a little too complicated to say, well, let's just multiply both sides by the reciprocal of the number. Instead, we just think of this as, hey, just divide by 3, okay? And any way you go, you're going to end up with the same result. 3 times a third and is the same as 3 over 3. And so we just get x. And same thing here. I can do 9 times 1 over 3. Or I can just divide my 9 divided by 3 and then times it by 1. I'll do 9 times 1. I get 9 over 3. And then that equals just 3. So you should be very comfortable with, again, operating on fractions because we're actually going to be doing it an awful lot. We're going to be working on fractions an awful lot. So you have to be very comfortable with this. Okay, let's move on in the book. Okay, so we have our first problem. It says solve 4x minus 20 equals 8. Be sure to check your answer. So I'm going to come over here now. My problem is 4x minus 20 equals 8. And I want to isolate my term. And so what I'm going to do is get rid of the 20. I need to balance this equation out. So I'm going to add 20 to both sides. To the left-hand side and 20 to the right-hand side. And after that, I'm just going to bring everything down. Okay, I get 4x. Those go to 0, so there's nothing to write. Equals just 28. So 4 times what number is equal to 28? Well, we divide to get rid of 4 times the x. We can divide both sides by 4. And we end up with 28 divided by 4 is 7. And so there it is. My answer is 7 there. I could check that by plugging, let's see, hold on, let's see here. My original problem is 4 times x minus 20 equals 8. Let's see, let's check that. 4 times 7, let's plug 7 into x. Let's see if it's true, if we get an identity or not. Turns out that I get 28 minus 20 equals 8, and that's 8 equals 8. And everybody knows that this is an identity. That's a true statement. 8 is equal to 8. That's called the reflexive property. And so we can stop that. And that proves that it's true. X equals 7 is indeed the solution for that. Okay, so now there are 2 problems, and these 2 you are to try. So what I'll do is allow you to pause the video, jot these down in your notes, and then we're going to actually go over the solutions to these, okay? So let's get into it. The first one, 5x minus 3 equals 12. And when I add 3 to both sides, just writing a line to show that I'm actually just going to be bringing these things down. We get 5x equals 15. And now, in this particular case, I need to get rid of the 5, and the way to do that is to divide both sides by 5. Okay, and then when that happens, the x goes away, and I get x equals just 3. Okay, and to check, yes, plug 5 times 3 in there, subtract 3 from it, and see if you get 12 or not. In fact, you do. 15 minus 3 equals 12 is a true statement. And that proves that that is indeed the answer. There was a second problem, part B, should say. So the first thing we want to do is isolate the x term. And so we have to get rid of that positive 2. So positive 2 is being added on the left side. So what we can do is subtract 2 from both sides. Okay, we end up with 4x equals negative 10 minus 2 is negative 12. Okay, that's like if you lost $10 and then lose another $2, you're down to negative $12. And now divide both sides by 4. When I do that, I get x is equal to negative 3. So for the first one is 3, and the second one is negative 3. All right, let's move on from there. The next problem, it looks like we have variables on both sides. And so what we'd have to do is just collect our variables terms on one side and our number on the other side, okay? And so what they decided to do is subtract x from both sides, you bring it down. That looks pretty clear. 2x minus 4 equals 3. And now it just becomes a routine type of problem. Isolate your x term, subtract 4 from both sides, or if we have a minus 4, add 4 to both sides, so on and so forth. And we end up with x equals 7 over 2. So now it's actually our turn. What we're going to do is solve one of these. The media example says it's to solve the equation 4x minus 3 equals 2x minus 1. So I have 4x minus 3 equals 2x minus 1. So again, variables on both sides. There are several ways to do this problem. What I usually do is I prefer to work with my variables. I try to keep my variable terms, my x terms, on the left-hand side. And so for that reason, I'm going to cross him out here. I'm going to cancel him out here and bring him over to the other side. So what I'm going to do first is minus 2x from both sides. And now rewrite the entire problem. I'm getting 4x minus 2x is just 2x minus 3 equals, that's gone now, minus 1. And so now I just get down to business. I need to isolate my x term, so I can add 3 to both sides now. Notice that I could have added 3 in the first place and then subtracted 2x. It does not matter the order in which you proceed, as long as you end up with an equivalent equation here. Now, negative 1 plus 3 is just 2. And now 2 times what number will give me 2? Turns out if you divide, actually show mathematically, x is equal to just 1. And a simple check will actually show that, yeah, it's true. X equals 1 is the solution. If I replace x for 1, and then 2 times x, I replace x again with 1, minus 1, what will I get? 4 minus 3 equals 2 minus 1. I end up with 1 equals 1. That's an identity. That's a true statement. We know for sure. Okay? That is, again, the reflexive property. And so that shows me that it is a true statement when I substitute 1 for x. It is the only solution. When we're solving linear equations, we should get a unique solution if the solution exists in the first place. Okay. There are 2 problems that I want you to try. Pause the video, work these problems out, and then we're actually going to go over them. Okay, so let's do that now. The first one, 5x plus 1 equals 12 minus x. Subtract 1 from both sides this time. I'm actually going to get rid of my minus 1 first. Again, it does not matter. I have just 5x on this side equals 11 minus x. Not quite done. Now what I have to do is add x to both sides. Okay? When I add x to both sides, I end up with 6x equals 11. And now I can just divide both sides by 6. Now, when I divide both sides by 6, I'm left with 11 over 6. That is fine. That is the answer. I don't have to convert it into a mixed number. Usually, Improper fractions are fine as long as they're reduced. And obviously, I cannot reduce this fraction. 11 is prime, and 6 isn't a multiple of 11 or anything of that sort, and so I cannot reduce. If I wanted to change it into a mixed number, I would just simply divide 6 into 11. I take the remainder of 5 and stick it over 6. Well, 5 parts out of 6. 1 and 5/6 is the equivalent answer. But again, we weren't asked to do that. 11 over 6 is the answer. The next problem we have here, it's 4x plus 2 equals 10x plus 1. So what I'm going to do is collect my x's. I'm going to get just my x's on the left. I don't want to have x's on the right. I want my x's to be on the left. So I'm going to subtract 10x from both sides. Notice when I do it, I put them under the like terms. It makes it easier. 4x minus 10x puts me at negative 6x plus 2. Bring the 2 down. And on the right-hand side, all I have is just 1. Now it's time to solve for x. Let's isolate the x term, so I have to get rid of the minus 2 now. What's left? Negative 6x is equal to negative 1. And when I divide both sides by negative 6, I end up with the fraction x is equal to a positive 1 over 6 now. A negative divided by negative makes a positive. And so my answer for this is 1/6. All right, let's move on. Now it appears they're starting to get a little bit more complicated. Not only do we have variables on both sides, we have an x term here and an x term there. It appears to be unsimplified. We have to utilize the distributive property in order to multiply these things out. So let's go over this together. Actually, I'm going to just start by doing a problem. I'm going to rewrite this problem first, and then let's just do it step by step. The problem is 4 parentheses 3 minus r plus 2 is equal to 3 times r plus 2. All right, and so again, it appears to be unsimplified. So I need to simplify the left-hand side, and then I need to simplify the right-hand side. The left-hand side, I can simplify this pretty easily. I need to just distribute first, and I'm going to use the distributive property. The distributive property says that whenever you have a number being multiplied by a 2 type of term expression here, you distribute the 5, you multiply it to both sides, and it will be equivalent. So 5 times 3 is 15. And bring down the minus sign, and then 5 positive 5 times the negative r, it is 5r. Now plus 2, just bring him straight down. And now what do we do to the right hand side? You should say yes, distribute the 3. So here we go, distribute that 3. I'm getting 3r plus 3 times 2 is 6. Now we need to simplify this a little bit more. We're not quite done simplifying this out. Okay, so when I simplify this, and in fact, I'm going to have my variable out front. So I'm going to have negative 5r. 15 plus 2 is really 17. Notice the 15 is a positive number. It doesn't have a negative next to it. The negative is paired with that 5. So it is a positive 15 plus 2. That's why we have 17. And I'm just going to rewrite this. 3r plus 6. Now, I want my variables on the left side only, so I'm going to get rid of that 3r by subtracting it from both sides, the entire term. Okay, let's bring this down. I'm going to rewrite this problem. I get negative 8r plus 17 is equal to just 6. Notice the 3r's cancel nicely for us. Okay, and now I need to, again, isolate my r term. So minus 17 from both sides. Okay, this is starting to get a little fun because we're solving our equation systematically. Negative 8r is equal to 6 minus 17, and that puts us at negative 11. And now divide both sides by negative 8. We get r is equal to positive 11 over 8, and that's the final answer. Let's do a couple more. Here's the next problem. It says 3 times 2p plus 8 is equal to p plus 24. Well, we can do this problem first. I need to simplify the left-hand side. Wouldn't that just be 6p plus 24 on the left-hand side if I distribute my 3 across? On the right-hand side, I'm just going to get p plus 24. And so now I just got to keep solving. Minus 24p minus 24p, that puts me at 6p equals p. Now minus p from both sides, actually. Minus p from both sides. 5p equals 0. Divide both sides by 5. Now you can divide into 0. You get 0 every time. So p is 0. And the check, I'll leave the check up to you. If you substitute 0 back into the original equation, you should get an identity. It appears you'd get 0 plus 8 times 3, which is 24, and 0 plus 24 is 24. So you get an identity there. The next two problems are designed for you to try on your own. And then what we'll do is go over the solutions to them. All right, pause the video, solve the problems, and then you're going to check our work, make sure we have the same answer and that it's understood. And the first problem is 4 times x plus 3 minus 2 times x minus 1, all equal to 0. We need to simplify the left-hand side. So here we go, distribute. Now distribute the negative 2 across. It's going to become negative 2x. And now negative 2 times negative 1 is a positive 2. Okay, a lot of people go wrong sometimes when they distribute a negative number and multiply by another negative number. You cannot forget about that. Okay, 4x minus 2x, these are like terms, and these are like terms. Now 4x minus 2x is 2x. Positive 12 plus 2 is 14, and it's all equal to 0. I need to isolate my x term, so I have to subtract 14 from both sides. It turns out that I get 2x equals negative 14, and now divide both sides by 2. X is equal to negative 7. Let's do the next one. 5 times x plus 2 is equal to 3 times x minus 3. Okay, let's distribute the 5. We get 5x plus 10 equals 3x minus 9. Now it's time to get rid of this x term, so minus 3x from both sides. I'm getting 2x plus 10 is equal to negative 9. Now let's isolate our 2x so we can get rid of that 10 by subtracting 10 from both sides. I get 2x is equal to negative 19. And now divide both sides by 2. To cancel the 2 out there, you get x is equal to just negative 19 over 2. That is the answer. Some of the problems in this section may not have solutions. They were just designed to fall apart. So be aware if you ever solve something and you end up with a false statement, then you've either made a mistake or the problem has no solution. So be sure to check your work. These are designed to fall apart in the end. So you just have to say, hey, there is no solution. And the other case, the other extreme case is when you solve an equation and you get an identity in the end. Like for example, 4x plus 12 equals 4x plus 12. If you solve it and you get an identity, that implies that there are infinitely many solutions that all real numbers will satisfy the equation. Um, those are the two extreme cases. All right, let's get down to business now. As promised, we're going to solve some of these linear equations that actually have fractions in them. And this is a level of difficulty, but again, you must have mastered the concept of fractions in order to really understand this. There are several different methods to proceed. So let's just jump right into it. The first problem is 1/2 x plus 3 equals 3/4. The best way to go about approaching this problem is to think about getting rid of the fractions. And in order to get rid of the fractions, you have to um, find the lowest common denominator. Because if you can find your lowest common denominator, all you got to do is multiply both sides by it. Now, all my fractions, you got to size them all up. I have 1/2 and I have a 3/4. So I have two fractions in this problem. The denominator is 2 and the other one is 4. So what would the common denominator be? What could I change them both into so that they both be the same? I can change them into both of them into 4. This one is already 4, so I don't have to change it at all. The LCD is 4. And so what I can do is multiply both sides by the LCD. Okay? And so what I'm going to do is multiply the left side by 4 and multiply the right-hand side by 4. And so when I multiply both sides by 4, I got to distribute him in there. 4 times a half is the same as 4 over 2. 4 over 2 is 2x. 4 times 3 is 12. And the same way here. Again, when you're multiplying a whole number, you have a choice. You can either multiply the numerator by the whole number first and then divide, or you can divide first and then multiply the result by the numerator. In this case, it's just you can just divide first, and it's immediate that they cancel out. You get 1, and 1 times 3 is still 3. So I've reduced my problem a great deal. I've had a complicated problem, and by multiplying both sides by the LCD, it will always clear the fractions because it's the least common denominator. And then you can work with this problem now. It's just your regular linear equation, 2 steps. Isolate your x term, minus 12 from both sides. We're getting 2x equals negative 9. And now divide both sides by 2. You end up with negative 9 over 2. So the 2 transposed to the other side. My final answer is x equals negative 9 over 2. And they agree with me as well. Let's do a few problems. We actually have a media example here. The problem is 3/5 times x minus 3 plus a half is equal to 4x plus 1/4. Okay, so I actually have three fractions in this problem. I have 3/5, a half, and a fourth. What's my LCD? What's the LCD? What would be the least common denominator between 5, 2, and 4? And you should know that it's 20, okay, which is the least common multiple as well. The least common multiple. If you count by twos, count by fours, and count by fives, the least common multiple would be 20. Um, and so 20 is what we have to multiply everything by 20. I got to multiply this by 20. I got to multiply this term by 20. I got to multiply this term by 20. And I got to multiply this term by 20. When I distribute my 20x 20 times, I have to multiply every term by 20. 20 divided by 5 is 4. 20 divided by 5 is 4. Let me say that one more time. 20 divided by 5 is 4. And then 4 times 3 is 12. So I got 12 for that. Now, why did I decide to divide first? Well, it's easier. That makes the number smaller. And I knew it would divide it because 20 is a multiple of 5. So it will always divide it evenly. 20 divided by 5 is 4. And then 4 times 3 is 12. Let's move on. 20 times 1/2. Well, 20 divided by 2 is 10. 10 times 1 is just 10 equals 20 times 4x is 80x. And now 20 divided by 4 is 5. I'm going to rewrite the problem and distribute my 12. I'm getting 12x minus 36 plus 10 is equal to 80x plus 5. Simplify a little bit more. We do have some like terms in there, so that we can simplify that out. That's 12x minus 26 equals 80x plus 5. And now I have to make a decision. Do I want my x's on the left-hand side and my numbers on the right? Yeah, so I'm going to cancel my x term out on this side and bring them over here. Okay, we end up with negative 68, I believe. X minus 26 equals positive 5. Now it's time to isolate the x term, which means I need to get rid of the negative 26. I have to add it to both sides. The inverse operation will get rid of it. We have negative 68x is equal to 31. And now all I have to do is divide both sides by negative 68. And if I divide both sides by negative 68, I get x is equal to negative 31 over 68. Final answer. Notice how the negative 68 originally became a positive 68, and I just brought the negative up because a positive divided by negative makes a negative. Final answer. And I cannot reduce that. 31 does not go into 68. Okay, we do have a problem for you to try. We have a few problems to try. Give it a go, see how you do. Pause the video, work them out, and we'll go over them together. I have two fractions in this problem. I want to get rid of them. I want to multiply both sides by the LCD, which is 10. So I'm going to multiply this side by 10. And I'm going to multiply the 1/2 by 10. Okay, 10 divided by 5 is 2 times 3 is 6. Notice that I don't multiply my 10 by this term. All right, you don't distribute across the product. I've multiplied and I'm done. Now on this side, I got to do 10 times 1/2. Well, 1/2 of 10 is 5. Now let's simplify the left-hand side. It's unsimplified. I need to distribute my 6. I need to isolate my x term, so add 12 to both sides. And now I just need to divide both sides by 6. Okay, so I'm getting 17 over 6, and I cannot reduce that. That is the answer. The next problem, give it a shot. Let's rewrite this. It's 3/2 times x minus 2 is equal to x minus 2 over 3 plus 1. Now, we do have a fraction. We have two fractions, 3/2 and x minus 2 over 3. So let's look at the denominators. It's a 2 and a 3. What's the LCD between 2 and 3? Wouldn't that just be 6? So let's multiply both sides by 6. Okay, now this time I will have to distribute my 6 across there. This time I will not over here. 6 divided by 2 is 3, times 3 is 9. 6 times the 3 is 2, so I get 2 times x minus 2. And now 6 times 1 is 6. Let's simplify this, distribute. Simplify this out a little bit more. 9x minus 18 is equal to 2x plus 2. I'm going to add my 18 to both sides. I get 9x equals 2x plus 20. Now I'm going to subtract 2x on both sides. I'm getting 7x is equal to 20. So x is equal to 20 over 7. Final answer. Um, I hope this video was useful. Be sure to do the practice problems. Um, we do have a gang of them, 1 through 30. Do as many as you can. If you have questions about them, reach out to me, send me a message, comment. Pretty easy to get a hold of. Take care. Have a great day. And I'll be in touch.